If you could travel within a crystalline solid, you would see the particles, atoms, ions, or molecules arranged in a regular array. Here, the spaces are greatly exaggerated, but in reality, the particles are packed close together. The unit cell of a crystal structure is the smallest portion that defines the structure. Stacking unit cells next to each other in all three directions gives the structure. Many elements and simple compounds have unit cells from the cubic crystal system. Let's examine the three types of cubic unit cells. All cubic unit cells have particles at the corners of a cube. The simple or primitive cubic unit cell has particles at the corners only. In reality, the particles lie as close to each other as possible. Note that the particles touch along the cube edges, but not along a diagonal in the face or along a diagonal through the body. By slicing away parts that belong to neighboring unit cells, we see that the actual unit cell consists of portions of the particles. When the cells pack next to each other in all three dimensions, we obtain the crystal. If we fade the others out, you can see the original group of 8 particles within the array and the unit cell within that group. We find the number of particles in one unit cell by combining all the particles' portions. In the simple cubic unit cell, 8 corners, each of which is 1/8 of a particle, combine to give 1 particle. A key feature of a crystal structure is its coordination number, the number of the nearest neighbors surrounding each particle. In a simple cubic array, any given particle has a neighboring particle above, below, to the right, to the left, in front, and in back of it for a total of 6 nearest neighbors. The body-centered cubic unit cell has a particle at each corner and one in the center, which is colored pink to make it easier to see. With full-size spheres, you can see that the particles don't touch along the edges of the cube, but each corner particle does touch the one in the center. The actual unit cell consists of portions of the corner particles and the whole one in the center. 8/8 give 1 particle, and the one in the center gives another for a total of 2 particles. In this tiny portion of a body-centered cubic array, you can see that any given particle has 4 nearest neighbors above and 4 below for a total of 8 nearest neighbors. The face-centered cubic unit cell has a particle at each corner and in each face, which are colored yellow here, but none in the center. The corner particles don't touch each other, but each corner does touch a particle in the face, and those in the faces touch each other as well. The actual unit cell consists of portions of particles at the corners and in the faces. 8/8 at the corners gives 1 particle, and half a particle in each of 6 faces gives 3 more, for a total of 4 particles. In this tiny portion of a face-centered cubic array, notice that a given particle has 4 nearest neighbors around it, 4 more above and 4 more below for a total of 12 nearest neighbors.